Okay guys, today we're going to be talking about the cation exchange capacity. Right? Cation, positively charged minerals, exchange, the ability to be exchanged into soil nutrient, and the capacity. Stated as CEC or TEC, total exchange capacity or cation exchange capacity. It's a measure of the negatively charged sites of the soil. Okay, so if we look at it, that there's a soil particle just there, and it might have these negative charges. So that's likely to check the cations: calcium, magnesium, potassium, and sodium. So to measure the exchange capacity, we need to know how much that is, or how many of those are. Now this can be a little bit difficult, and there is a calculation for doing that, but I'll give you an idea to start with what actually happens. If we look at it, that when a test is taken, we work on the scenario that it's not a weight of the soil that's tested, it's actually the amount. So if we say this is a cup, for instance, and it's full of soil, right? So what we're going to do is measure the amount of negatively charged sites inside of there. And then you can extrapolate that out to the size of the soil. So whenever we're looking at a soil sample, we're always looking at around 150 mils deep. In America, 6 inches, and over there it's quantified in 6 inches per acre, and we quantify it into 150 mils per hectare. They have very similar figures. Okay, so what happens here is that, let's have a look at it. Like, say we get a really heavy clay soil, and if you imagine inside that cup, that the heavy clay particles, there's millions of them, just millions of them, and they've got lots and lots of negatively charged sites. So like if we looked at that soil particle, a clay particle might have gaps in it here, and there might be negative charges there around the outside, and because there's so much density, there's so many negatively charged sites. Now if you look at a sand particle, and let's put this in context, that might be the size of the sand particle, and it might only have 4 negatively charged sites, where this tiny particle might have 10. So when you jam that together, you can actually see that there's a lot more negatively charged sites in heavy clays. So what you're looking at is whatever the soil type is within that measurement, you're actually just going to measure the negatively charged sites. The biggest factor in all of these is particle size here, and one other factor: organic matter. So if you take a peat soil with high organic matter, it may have a CEC of 40. Heavy clay, 30. Sand might only be 4 to 6. And the same ratios look at volcanic soils as well. Okay, so what happens? It goes to the laboratory. The first thing they do is they measure the pH, and then they measure calcium, magnesium, potassium, and sodium. Then a calculation is done from the pH and the measurement of those 4 cations, and it will end up giving you the CEC. Now, CEC is on top of the page in your soil test, and it's the first thing that you should look at, because what's going to happen from there, all the rest of the calculations start. So at the top of your soil test, we see CEC, and say we call it 30. So we know, okay, it's either organic soil or it's a heavy clay. First of all, you have to know what you're dealing with. So once you've got a clay soil, okay, so that means that it has told you that inside that measurement there was a lot of soil. and it would have been very heavy. But remember, the measurement wasn't based on weight, it was based on measurement. So what happens here, if we start to change that soil, say like we start to flocculate it and aerate it and get calcium into it, magnesium into it, biology, humus, all of a sudden, say this is the whole measurement of the soil here in that cup, what was there, you'll actually find out the cuppeth runneth over and extends. But when we go back and test the soil again, all of a sudden we might see the CEC drop to 20. Now it doesn't mean that the soil's disappeared, it just means that the soil has expanded, which is great, because once we do that, then we get a bit of water coming down, water goes back up, more nutrient availability, the roots can get between them all. Marvellous stuff. Now if we look at a sand soil like this, and it's got a CEC of 4, well, it's hopeless. I mean, there's no water going to be held in the soil, it's just going to disappear, it'll get dry in the summer, will be good in the winter, it'll be wet, it'll be dry in the winter, and it'll be dry in the summer as well. So to make this work, we actually have to get organic matter in. So we need what we call humus. Now the interesting thing about this, if you've got low mineral, you actually need to put more mineral on so that the humus can grow, so that the capacity will expand. Well, the interesting thing about this, when you have a heavily packed soil, it will actually do the same thing. It will expand. It will lose that density. So like we've gone from there and we've expanded out to here. But then we add in, the humus starts to come in. And if we get it really well, we'll get 7% organic matter. And the interesting thing is that the CEC will end up around 9 to 10. So that soil is really effective. It's great. In this heavy clay material, we'd like to see that come down to about 14. Takes time. There's a lot of variances, and we'll go through that as we move on in the course. So this is the CEC. We're measuring inside a cup how much negatively charged soils there is. Then it's extrapolated out to 150 mils per hectare, or 6 inches per acre. And we just worked out how much it is. Now to go one step further, no, we'll stop there.